Hey everyone, welcome to the Math 6 7.6 video. Today we're talking about solving inequalities using addition and subtraction. Alright, so just as a quick recap, I want you to pause the video and I want you to not write any of this down as it is, but I want you to arrange these different words with the given signs. Play the video when you're done. Alright, so I hope that your notebook now looks like this. Okay, so we have to make sure we're good on that. Need to memorize exactly, what directions these different signs face. And so remember, like, the less than's kind of easy, because if you draw a less than sign, you take it and you kind of spin it. It kind of creates a L. If I can get this one to do it. Oh, it won't spin on me right now, but you know what I'm talking about. Maybe a little bit bigger. There, that's a little easier. Kind of creates an L for less than, okay? And then remember these little lines under here, so that's greater than or equal to, and then less than or equal to. Alright, so let's talk about the addition property of inequality, and really what I want you to see here is the inverse, okay, when using addition as the inverse operation. And basically what the property says is that if you do something to one side of an inequality and you do it to the other side of the inequality, everything still stays true. It's a true statement. So if you start with x minus 4 is greater than 5, if you add 4 to this side and add 4 to that side, you're keeping things true, okay? So if there's some number minus 4 that is greater than 5, okay, well then if I add 4 and add 4, it's still true down here that is some number is greater than 9. So what would be an example of an answer there? Well, think about it. What this says is our answer is a number that's greater than 9, okay? So what would be a number that's greater than 9? 10. But isn't 11 also greater than 9? What about 20? What about 34? Yeah, those are all numbers that are greater than 9. And so we have more than one solution, okay? So we have more than one answer here. So 10, if we plugged it in there, is 10 greater than 9? Yeah, so 10 is a solution. If I plugged 11 in there, is 11 greater than 9? Yes, so it's a solution. If I plug 20 in there, is 20 greater than 9? Yeah, so it's also a solution. So all numbers, what that X stands for in an inequality is what we call all real numbers. All real numbers that are greater than 9 are solutions. Alright, so kind of the opposite is the subtraction property of inequality. And again, we just really want to think about inverse, okay, or opposite operations. And so if we had a 19 is greater than some number plus 4, okay, and I subtraction property, okay, the same number from both sides, I'm maintaining a true statement. So if I subtract 4 and subtract 4, this 19 is greater than c plus 4 becomes 15 is greater than c, because those cancel each other out. And remember, one thing that we need to be sure of and need to make sure we do is with inequalities, we want to write our variable on the left in our answer, the number on the right, and then we just need to make sure we change the sign correctly. So here it was pointing to the C, so we're going to flip it around here so it's still pointing to the C. Now, these two actually mean the same thing even though the sign is pointing in a different direction, but that's because up here it was eating the 15 and pointing to the C, and it's still pointing to the C and eating the 15. And so what would be an answer here? Well, C stands for, like we said up above, all real numbers that are less than 15. So for example, what's a number that's less than 15? 9, 2, 7, negative 10. So if we plug them in, you could say, well, okay, is 9 less than 15? Yeah. Is 2 less than 15? Yeah. Plug them in back here. Is 19 greater than 7 plus 4? Well, 7 plus 4 is 11. And so would 19 be greater than 11? Yeah, so that works also, right? All of these numbers are solutions, but that's why we write it like this, because it would be impossible for us to write every single number that is less than 15. It would take us an infinite amount of time. You'd never finish it because numbers go on into infinity. All right, so take a minute here, and I want you to solve these. Play the video when you're done. All right, so hopefully you recognize that just like in equation solving with inequalities, we want to do the same thing to both sides and get the variable by itself. So I've got this y here, and he's not by himself because he's got a positive 4 with him, so let's subtract 4 from both sides. And now I have a y, got a less than, and then what's negative 3 minus 4? It's a -7. That's our answer. Now, if we were to graph our answer, we go to -7, open circle, and we shade to the left. All right, down here, 9 is greater than or equal to r minus 7. The r is not by himself. Why? Because he's got -7, so that's add 7. Again, we have to add to both sides, addition property of equality there. And now I get 16 is greater than or equal to r. Again, we want to make sure we spin that around, put the r there, put the 16 there. And again, it was pointing to the r. Just make sure it's still pointing to the r. So our answer is all real numbers that are less than or equal to 16. Now, for this one, let's check our work real quick. What's the number that's less than or equal to 16? What about 0? Let's try 0. So 9 should be greater than or equal to 0 minus 7. Well, 0 minus 7, that's -7. So is 9 greater than or equal to -7? Yeah. So our answer here, when we picked one of the answers, the numbers that fits this, gave us a true statement. So it's starting to prove that we were right. All right, so let's say you received a $100 Amazon gift card for your birthday. As a Prime member, you're also going to get free shipping. So you already have $27.89 worth of items in your cart, and we're going to write and solve an inequality. It's going to help you determine the additional amount on your gift card that you can spend. Now, can is the key word here, the operative word. Why? Well, because think about it. If you go to Amazon.com, does anybody force you to spend $100? No. Could you choose to buy an item that's $1? Yeah, right? So we have some freedom here. So how would we logically write this, and then we'll solve it? Well, let's think. I've got some sort of total here that I could spend, right? It's $100. I'm going to write that off to the right. I like to write my totals on the right. But how would I get to 100? Well, I've already put some stuff in my cart, right? Yeah, I put $27.89. So we've got this $27.89 of stuff that's already in our cart. But I could add to that cost by putting more items in my cart, right? You know, I could buy a pair of headphones. I could buy toilet paper. You could buy anything on Amazon. So maybe other items, right? So what do we, I don't know what the cost of the other items are, so what do? Variable, okay? And all of this stuff here is going to cost me money, but I'm only trying to determine the amount on my gift card, right? You know, I can spend using my gift card, so I don't want to go over. So all of this here needs to get me less than or equal to $100. So the cost of all the items needs to be less than or equal to 100. So that is writing it. Now let's go ahead and solve it. Well, what do? Well, whatever you do to one side, you have to do to the other. And I'm trying to get my variable by itself, so let's just subtract $27.89 from both sides. Right, and when you do that, let's see, this is 0, 0, so that'd be 11 cents there, and that'd be a 99, and so that'd be a $72.11. And they have x there, so x is less than or equal to 72.11. So what does that mean? Well, what it means is, let's go back here, right? This was the items the cost we had already put into our cart, plus the additional cost of items needs to be less than or equal to the amount on our GC, our gift card, right? So the X stood for the cost of additional items. So whatever we put in our cart needs to be less than or equal to $72.11, right? So could I buy a set of speakers that cost $50? Yes, and I still wouldn't spend over my gift card. But if I wanted to add, I don't know, like a new keyboard, a really fancy keyboard, and it was $80, that wouldn't work because 80 is not less than or equal to $72.11. All right, last one here. You're going to take a flight to Philly, and you're only taking a carry-on bag. The bag itself weighs 3.6 pounds when it's empty. Now, the airline requires that any carry-on bag weigh at most 40 pounds. So I want you to write and solve an inequality. It's going to help you determine the weight of the items that you can put into the bag, so the stuff you're going to pack, but you don't want to violate the airline policy. Okay, so how are we going to do that? I don't know. I think I've given you enough information to figure it out, though. So what we're going to do is, what you're going to do is get this done. Make sure to write it and solve it, and then you're going to bring it to class, and we're going to talk about it. So that's all I've got for you. Good luck on that, and I will I'm looking forward to seeing your work. See ya.